Okay, only 44 students joined. Okay, once again, good afternoon to all. So we'll start with the reinforcement learning. Can you see the slides?
Yes, ma'am.
Okay. Okay, so this is the last topic. So today and maybe one more class is required for completing reinforcement learning. Okay. Okay, so what is reinforcement learning? Okay, so in machine learning, so you would have learned many machine learning algorithms like maybe initially we studied linear regression, logistic regression. Okay, so many machine learning algorithms you would have learned. Again, another classification neural networks we learn. Okay, so all these things, it follows a particular learning algorithms. Okay, learning techniques it will be following. So what are the main learning techniques which is used in machine learning? Can anyone tell? All these algorithms we can classify mainly based on this learning algorithms, okay, learning techniques. So we can tell the machine learning algorithms, it is based on the learning technique like supervised, unsupervised, and the reinforcement learning. Okay, so whatever algorithms you learn, so maybe linear regression or logistic regression, again the neural networks, all that things, it belongs to any of these classifications. So that means using those algorithms, maybe we can do supervised. Okay, it may be using the learning algorithm, it may be based on supervised technique or unsupervised, or then till now we were covering only about the supervised and unsupervised. Okay, so next we have to learn about what is reinforcement learning. Okay, so first of all I'll just quickly go through what is supervised and unsupervised. Okay, so in the case of supervised, what we were doing, so we have a data which is labeled. That means the data will have the correct answer also with that. Okay, so with that we will be giving the training. So in the case of supervised learning, so there will be a supervision or there will be a guidance, that is we are giving the input and we tell that okay, this is the input, means what will be the output. Okay, so someone is there to oversee, or that what will be the output, we know what will be the output, and when we predict it, if it is deviating from the output, how much it is deviating from the output, and based on that, how that in the next iteration, how it should change the weights, all that things we can decide it. Okay, so in the case of supervised learning, can you all mute? One second. Okay. So for example, okay, so when we consider that, okay, I am predicting your grades based on the marks. Okay, so maybe I have a data for 5 years in our college. Okay, so for these marks, these are the grades. So in the case of supervised, what we will do, maybe 60% or 75% of the data we will use for training, where we know, okay, that this is the input or this is the marks, means what should be the grade, so that we know. Okay, so with that we will give the training, and again later we will, when we do the testing, okay, we will check with the answer whether it is correctly predicting or not. So based on that only we study the performance measures, accuracy, all that things. Okay, so how much, whether it's correctly predicting or not, how much we are correctly predicting, how much we are not correctly predicting, all that things we can find it out from the supervised learning. Then the other one, unsupervised learning, means maybe consider the same example where we have only the marks, we don't have the grades. Okay, so only I am giving the marks and I am asking, okay, make it into 2 groups or 3 groups. Okay, so then what it does, based on the similarities, the hidden patterns or the similarities in that marks, based on that it will do divide the into clusters or the groups, okay, which has a similar patterns. Based on that it will be doing the clustering. Okay, so that is the unsupervised learning. So now what will be this reinforcement learning? Okay, so consider an example that, okay, maybe you think that you got stuck in one island. island, okay, so which is isolated, okay. And in that case, what will you do? Suddenly maybe you will get panic, and after that, what will you do? You have to survive somehow. You have to survive over there. So what will you do? You will explore, okay, and you will be finding, okay, what I can eat, okay. The basic need is we need food, so we will search for, and so we will find out something, and we don't know whether we can eat that or not, okay, so we will experiment on that, okay. So we will eat that one, and we will try whether something is happening, okay. All that things we will be experimenting, and later you will learn how to survive in that particular island, okay. So there we call that the person, okay, who maybe you got stuck in the island, means that we call it as the agent. In reinforcement learning, we call it as the agent. So the agent, they will try to explore in a particular environment. So considering this example, the environment is island, okay. So they are trying to explore, and from the scratch, they initially they don't know anything about the island. So it is a kind of trial and error experiment, and they will be from there, they are trying and learning, okay, maybe what to eat, okay, where to sleep, all that things you are trying to learn from that one, okay. So that is in the reinforcement learning, we mainly use these terms agent, okay, and the environment, okay. And based on that, that is when we explore that environment, the agent will be doing some actions, okay. So that for that actions, each actions, it may be getting some rewards, okay. Some rewards means maybe like, okay, when you eat something, maybe it is having some bitter taste, or maybe while after eating you feel some giddiness or something like that, then you will understand that, okay, I should not eat that particular thing. So next day onwards you may not eat that. So maybe there's something else when you eat, okay, it is very tasty, and after that, okay, you feel some kind of energy, all that things, okay, you will understand that, yeah, I should eat this particular thing. So it is a kind of reward, okay. So when agent explore in that particular environment, they will be getting a particular reward. So based on that reward, sometimes it may be positive, or sometimes it may be negative, okay, or some negative reward or positive reward. So based on that, it will understand, and it will try to maximize the positive rewards, okay. So in that particular situation, the agent, when it try to explore, it will always try to maximize the rewards, okay. That means the positive rewards, okay. So mainly this reinforcement learning, it is used in robotic path planning, then in the gaming, okay, then again in the self-driving cars and all, we will be using reinforcement learning, where it is difficult to give the training with label data. So in that situations, we will usually go with the reinforcement learning, okay. So you consider that, for example, some gaming. So in the case of gaming, it may be difficult to provide the entire data. It may be difficult to provide the entire data in the sense, maybe like suppose you just consider the chess game. So there may be different moves will be there. So maybe a player is making a move, maybe you have the like components like maybe king, okay, or maybe queen or bishop, maybe whichever it is. So you are making a move, okay. Then the machine, it has to understand, and it has to again make a particular move. So there may be many cases, okay, when the a particular maybe king or anything, when you make a move, then there will be many possible cases will be there, okay. So in that case, if you are trying to apply the supervised learning, then it is difficult to capture that much data, and we need to give the training. So that may be difficult, because many situations, many moves will be there. So it may be difficult to collect the data and label it and provide it and give the training, okay. So instead of that, when we use a reinforcement learning, it is tried to observe, and it tried to explore, and it will be a kind of trial and error method. It will be experiencing, and from that it will try to learn. So each time, maybe the initially the machine, it may fail, but later on it will be trying to learn from that experience while playing with the opponent, maybe with the human being. When the machine plays, okay, it is trying to learn from that human being how it is playing. So initially maybe the machine may fail, but slowly it will be learning, and finally maybe it may outperform the human being, okay. So reinforcement learning means it is a kind of trial and error method, and it is experiencing from that, and it is learning from that experience. Okay, so you may be knowing some machines like IBM's one of the supercomputer, that is Deep Blue. That with the world chess champion, that is with the Gary Kasparov, there was a game, and in that play, initially the Kasparov won, but later the machine, that is the Deep Blue, the machine, it has won. Okay, so now suppose we use a supervised learning. What happens is, if suppose you just consider that, okay, I want to use a supervised learning in the case of any gaming. So what we do is, we can collect the data and we can label and give, because though it is huge data, we can collect the data and we can label the data and give it. But what happens is, the machines, it will try to imitate. Maybe you just consider that a perfect player is playing, so that data we can collect it. Maybe one day how he is playing, that can be observed, and that entire data can be collected, and we can label it and give to the machine, and we can give the training. But what happens is, the machine, it may be trying to imitate that human being. It may not try to explore and learn from its experience. It will try to imitate, and in that case, what happens is, it may not be able to outperform the human being. Okay, but when we apply the reinforcement learning technique, it is maybe initially it may be failing, but slowly it is trying to understand. Okay, and it is trying to outperform the human beings. Okay, so various games you may be knowing. Okay, so again, another one, that DeepMind's AlphaGo. So for the game Go, that also outperformed and won against the human being. Okay, so I just want to show one video, 1 second, which explains about the reinforcement learning, just 2-3 minutes. Then after that, I'll continue again. I'll share it again with the audio. Yeah, can you see this? No.
Dynamic environment.
Can you hear?
So in this episode, I will give a general introduction to the field of reinforcement learning, as well as an overview of the most challenging problems that we're facing today. If you're looking for a solid introduction into the field of deep reinforcement learning, then this episode is exactly what you're looking for. My name is Xander, and welcome to Archive Insights. A large audience of some of the brightest minds in AI and machine learning. So he showed this video where a robot is cleaning a living room, bringing somebody a bottle of beer, and basically doing a whole range of mundane tasks that robots in sci-fi movies can do without question. And then at the end of the video, Peter revealed that the robot's actions were actually entirely remote controlled by a human operator. And the takeaway from this demo, I think, is a very important one. It basically says that the robots we've been building for decades now are physically perfectly capable of doing a wide range of useful tasks, but the problem is that we can't embed them with the needed intelligence to do those things. So basically, creating useful state-of-the-art robotics is a software challenge and not a hardware problem. And so it turns out that having a robot learn how to do something very simple, like picking up a bottle of beer, can be a very challenging task. And so in this video, I want to introduce you guys to the whole subfield in machine learning that's called reinforcement learning, which I think is one of the most promising directions to actually get to very intelligent robotic behavior. So in the most common machine learning applications, people use what we call supervised learning. And this means that you give an input to your neural network model, but you know the output that your model should produce. And therefore, you can compute gradients using something like the backpropagation algorithm to train that network to produce your outputs. So imagine you want to train a neural network to play the game of Pong. What you would do in a supervised setting is you would have a good human gamer play the game of Pong for a couple of hours, and you would create a data set where you log all of the frames that that human is seeing on the screen, as well as the actions that he takes in response to those frames. So whether he's pushing the up arrow or the down arrow. And we can then feed those input frames through a very simple neural network that at the output can produce two simple actions. It's either going to select the up action or the down action. And by simply training on the data set of that human gameplay using something like backpropagation, we can actually train that neural network to replicate the actions of the human gamer. But there are two significant downsides to this approach. So on the one hand, if you want to do supervised learning, you have to create a data set to train on, which is not always a very easy thing to do. And on the other hand, if you train your neural network model to simply imitate the actions of the human player, well, then by definition, your agent can never be better at playing the game of Pong than that human gamer. For example, if we want to train a neural net to be better at playing the game of Go than the best human, then by definition, we can't use supervised learning. So is there a way to have an agent learn to play a game entirely by itself? Well, fortunately, there is, and this is called reinforcement learning. So the framework in reinforcement learning is actually surprisingly similar to the normal framework in supervised learning. So we still have an input frame, we run it through some neural network model, and the network produces an output action, either up or down. But the only difference here is that now we don't actually know the target label. So we don't know in any situation whether we should have gone up or down because we don't have a data set to train on. And in reinforcement learning, the network that transforms input frames to output actions is called the policy network. Now, one of the simplest ways to train a policy network is a method called policy gradients. So the approach in policy gradients is that you start out with a complete...
Okay. So later you can watch it fully. Okay. So I just want to tell you that. So when we uses reinforcement learning is when we have the data. Okay. So when it's difficult to collect the data, so in that case, especially we will be using the reinforcement learning. So especially we have the dynamic environment where we have the games, especially in the games or in the robotic path planning or in the case of self-driving cars and all, it's difficult to collect, label the data and give it. Okay. So in that cases and all, mostly we will go with the reinforcement learning. And suppose if we try to apply the supervised learning in that case, what happens is maybe while watching video, you would have understood that, okay, we collect the data and give in the case of gaming. So what happens is it try to replicate the human being, or it will try to imitate the human being instead of learning from that one. So in that case, it may not outperform the human being. Okay. So that's a problem. Okay. So here also you can see in this example, the robot, when it tried to reach that diamond in this figure, you can see it may have many hurdles. Okay. So each times maybe when it come across a hurdle, it will be getting a negative reward. Okay. So if it's not come across a hurdle, it may be getting the positive rewards. So when it has to achieve the target, it will be always seeing how it will be getting maximum reward. So maybe the first time it may be getting the negative rewards or the errors. Okay. So maybe each time when it do that game, it will be learning from that, and each time when it play, slowly it is learning and it try to get maximum reward. Okay. So in the case of reinforcement learning, always it try to maximize the reward. So another example I'll tell you, maybe consider that there is a robot. Okay. So maybe I'm giving the instruction to the robot to get a glass of water from the kitchen. So maybe consider that I am sitting in a living room and giving the instruction to the robot to take a glass of water from the kitchen. Okay. So maybe wherever the robot is, from that particular point, from that particular position, the robot has to take some move and it has to reach the kitchen and it has to take glass of water and bring it to me. Okay. So in that case, what the robot does is from that particular position. So initially it may be exploring the path. So it has four moves. Maybe it can move to left side, it can move forward, it can move backward, it can move to right side. So four moves are there. So it does not know which has to be selected. Okay. So first it may be taking the maybe left side. It is taking the left side move. So now in this case, we may be giving that when the agent try to explore and try to learn, we will be giving that based on each action, it will be getting some rewards. It may be negative or positive reward. So when it takes a left move, if it's getting a negative reward, it will understand that the path which selected is wrong. So what happens is again, it will try to select maybe the other one moving backward. So again, moving backward, if it's getting negative reward, it will try to explore the other path moving right. So when it is correct, if it is a correct move, then it will be getting a positive reward. Okay. So then whenever it get the positive reward, okay, it will try to understand that, okay, it should select that path and it should try to avoid the other path. Okay, so then, okay, so initially maybe it will be doing many experiments. From that, it may be getting how much of a reward it is getting. From that, it will try to understand that, okay, whichever the negative rewards it got it, that paths are wrong. Okay, so then next time again this task is repeated again. If I am giving the instruction, take the glass of water, so maybe it will try to maximize the reward. So previously whichever path it selected, and if it understood that, okay, it is wrong path it has selected, it got the negative reward, so it will try to avoid it and it will try to maximize it positive rewards. Okay, so there is some comparison it showed between the supervised, unsupervised, and reinforcement learning based on each task. Okay, that is first definition. You know the definition of supervised, unsupervised, and reinforcement learning. Next, the types of problem. So supervised mainly deals with regression classifications that already you had studied. Then unsupervised, it is dealing with the problems like clustering, association, and all. And reinforcement mainly we use with the gaming, robotic path navigation, then again in the self-driving cars. Okay, all that we are using. Then types of data. In the supervised, you know that mostly the data will be the labeled data. And in the case of unsupervised, the data will be unlabeled. And in the case of reinforcement learning, there won't be any predefined data. The agent, it tries to explore from that environment, and it's a kind of trial and error method. And the agent itself will be responsible for collecting the data. And based on the rewards, whatever it gets, it try to understand which will be correct and which will be wrong. Okay, and next is training. So for supervised learning, always there is a supervision is required. Some guidance, or someone should oversee. That means we are labeling and giving the data. And again, if when we do the testing, if it's varying from the expected output, how much it is varying, okay, all that things we will be supplying. In the case of back propagation, you would have seen that that will be given again as the input, and the weights will be updated based on that. Okay, so in the case of unsupervised and the reinforcement learning, there is no supervision required. Okay, so in the case of reinforcement learning, it has to do the training by itself. That means all that thing, the agent is trying to explore from the environment and trying to learn it. And in the case of supervised learning, it forecasts the outcomes. That is, it predicts the outcomes. And in the case of unsupervised learning, it is trying to discover the hidden patterns. I told you, when you want to cluster the marks, it will try to look at the similarities in that marks, and based on that it will do the classification. And the case of reinforcement learning, it is a series of actions that is based on the rewards whatever it is getting. Based on that it will perform the action. And in the case of supervised, what kind of approach? Okay, it is labeled input. It is a mapping between the labeled input to the output. And the case of unsupervised, it try to understand the patterns and discover the output. And in the case of reinforcement learning, it's a kind of trial and error method. And in supervised and unsupervised, supervised, there will be feedback. That means how much it is varying from the output. Based on that, the feedback can be given, and again the next time the weights updation can be done based on that. But in unsupervised, there won't be any feedback. But in reinforcement learning, instead of feedback, it is a reward system. We tell it as a reward system. So each time, based on the rewards what it is getting, whether it is a positive reward or negative reward, whatever it is, how what kind of reward it is getting, based on that it will be following maybe the path, or in the game means whatever the move it makes, it will be based on the rewards. And whatever the popular algorithms used in supervised, you may be knowing. Unsupervised also, last class you had studied some of the unsupervised algorithms. And in reinforcement learning, we have some of the algorithms like q learning, then state action, reward, state action. So that kind of algorithms we have. And mainly the applications I told you, in case of reinforcement learning, mostly it is used for gaming, robotic navigation, and self-driving cars. Okay, So in reinforcement learning, we should understand what can be the input, what will be the input, and what will be the output, and how the training happens. Okay, so when you consider any example, maybe the gaming or robotic path navigation, so initially there will be an initial state, okay, that will be considered as the input. And from that state, okay, each time it may be having some actions, it observes the environment, and based on that, it may be some sequence of actions will be there, and for each action there will be some reward, and based on that reward, each time it will be again the action, it will change, and it will be moving from one state to another state. So maybe consider the robot has to move from the living room to the kitchen, so it may be taking the left direction. So if it's getting the negative reward, so what happens, it will again take another turn to the right side. So all these are actions. So for each action it may be getting the positive or negative reward. Based on that, it is moving from one state to another state. So it was initially idle, then it was making a left turn, okay, then making right turn, then again it is it understood that it should move to the front direction, so maybe the 4 steps or 5 steps. So each time it is performing an action, and for that it is getting a reward, and based on that it is moving from one state to another state. Okay, so the training, it's based upon the input, and the model will return a state, and the the agent will decide, the user will decide to reward or punish the model based on its output. So each time whatever the action it is doing, for that it may be getting some punishment or some rewards it will be getting. So based on, it will